Our group will present about metallization materials. The variables given to us are aluminium, copper, and alloy. Our group members are
Siti Aisyah binti Zul Alam
and me, Aina SYAZWIN binti Muhammad SHUKOR. As introduction, metallization is an adding process that deposits metal layers on a wafer surface. One of the variables in metallization is materials. Metals such as copper, aluminium, and alloy are very good conductors for metallization. However, each metals have different resistivity value. The selective of suitable material are really important because it can affect the metallization process and also can calculate sheet resistance. Thus, each materials have their pros and cons in metallization process. Next, animation flowchart. User will start by push the flag button. Then they can choose metallization materials which are aluminium, copper or alloy. If they choose aluminium, we will define resistivity aluminium which is 2.65 times 10 power of negative 8, and then we will ask for thickness. Then we will define their thickness as answer. Next, we will calculate sheet resistance, which is resistivity divided with answer. Then we will show the sheet resistance. After that, we will continue aluminium metallization process. It will be junction spike. Lastly, the animation will end. However, if they choose copper, we will define resistivity of copper, which is 1.65 10 power of negative 8. And then we will ask user for thickness. We will define their thickness as answer. Then we will calculate sheet resistance, which is resistivity of copper divided with answer. Then we will show the sheet resistance. After that, we will continue copper metallization processes, and it will cause heavy metal contamination and device malfunction. And then the animation ended. However, if they choose alloy, we will ask for silicon concentration, and if the answer is equal to 1%, we will continue alloy metallization processes, and it will produce aluminum silicon metallization. However, if the answer is not 1%, we will continue alloy metallization processes, but we will show try again. And then the animation ended. Next, we will explain about program source code. When the sprite push button is clicked, the backdrop will switch to intro and the push button will hide. When the backdrop switch to intro, user can read this table and click button next to switch next backdrop. When the backdrop switch to blue sky 2, the aluminium, copper and alloy sprites will show. The next process is chosen by the user which sprite they want to click. If they click aluminium sprite, the blue sky 2 backdrop will switch to aluminium backdrop. After the backdrop is switched, the transparent sprite will say the explanation of the chamber for 4 seconds. After 4 seconds, the flying cat sprite will show and ask to insert the thickness of the material and wait for the response. Then the response will set as answer. The resistivity of metal is set to 2.65 times 10 power of negative 8. The sheet resistance is set to resistivity divided by thickness. Then the sheet resistance variable will show at the left top screen. The flying cat sprite will give the explanation for 2 seconds. Next, it will say press 1 and wait until the key 1 pressed. Once the key is pressed, the purple sprite simultaneously glide to the coordinate stated and the process will continue until the key 3 is pressed and it asks to click the cat spirit. When the cat spirit is clicked, backdrop will switch to junction spiking. The sheet resistance and thickness variables are shown. The result and explanation are in the backdrop. User will start by push flag button and then push tab, and then we'll read the backdrop and then push next and choose aluminium. The invisible sprite will explain the process and then insert the thickness. Then press for the process, press 1, press 2, press 3 and click the cat. Then the result will show the thickness and the sheet resistance.
Okay, if user clicks on copper sprite, the blue sky 2 backdrop will switch to the copper backdrop. After the backdrop is switched, the sprite will say the explanation of the CVD chamber for 4 seconds. Okay, after 4 seconds, the butterfly sprite will show and ask for the thickness of material and wait for the response. Then the response will set as answer. The resistivity of copper metal is set to the 1.68 times 10 to the power of negative 8. Next, the sheet resistance variable is set to the resistivity divided by the thickness. Next, the sheet resistance variable will show at the screen. Then, the butterfly sprite gives the explanation for 2 seconds. Next, it will say press 1 and wait until the key 1 is pressed. Once the key is pressed, the purple sprite will guide simultaneously to the coordinate stated. The process will continue until the key 3 is pressed. Then, it will say to click the next sprite. Okay, next sprite will show at the copper backdrop after 15 seconds. When the sprite is clicked, backdrop will switch to the copper 2 backdrop. The sheet resistance and thickness variables are shown. The result and explanation are in the backdrop. Okay, if we click to the copper sprite, this is the explanation of the CVD chamber. And if we insert the thickness is 10 angstrom, the result of sheet resistance will be shown. And then we need to press 1, press 2, and press 3. And then click next sprite to see the result. So this is our result for copper metallization. As we can see at the left top, show the results of sheet resistance and the thickness, and thus our copper metallization is done. Okay, if user clicks on alloy sprite, when the alloy sprite click, the blue sky 2 backdrop will switch to the alloy backdrop. After the backdrop is switched, the sprite will see the explanation of the CVD chamber for 4 seconds. After 4 seconds, the elephant sprite will show and ask to insert the thickness of material and the concentration, then wait for the response. Then the response will set as an answer. Next, the concentration variable will show at the screen. Okay, after the elephant sprite gives the explanation for 2 seconds, next it will say press 1 and wait until the key 1 is pressed. As we can see that when key 1 is pressed, it also says the process for 4 seconds. And then once the key is pressed, the purple and the yellow sprite simultaneously glide to the coordinate stated, and the process will continue until the key 3 is pressed and it says to click the pink arrow sprite. The arrow pin sprite will appear at the alloy backdrop after 15 seconds. When the arrow pin sprite is clicked, we set the condition. If the concentration is equal to the 1, the backdrop will switch to alloy 2 backdrop. If the concentration is not equal to the 1, the backdrop will switch to the error. Okay, when the condition is true, the backdrop will switch to the alloy 2 backdrop. The thickness and concentration variable are shown. The result and explanation are in the backdrop. When the condition is false, the error backdrop will appear. Tap flag button to start all over again. Okay, if we click to the alloy sprite, the backdrop is changed, and then this is the explanation of the CVD chamber. If we insert 100 angstrom and then the concentration is 1%, so the concentration of the silicon will shown, and then we need to press 1, press 2, and then press 3, and then click the arrow sprite to see what happens. So this is our result for aluminum silicon alloy. As we can see at the left top is the concentration and the thickness result, and thus our aluminum silicon process is done. If we put the concentration is 0.1 and then click, so the concentration is 0.1 now, and then press 2, and then click the split arrow to see the result. So the result is try again because our concentration is not enough to proceed the process. Okay, next we continue with the variable calculation. In metallization process, finding the resistance value is one of the most important characteristics of conducting materials. With the value of resistance, a sheet resistance can be measured to determine the film thickness, since this method is much faster than profilament thickness measurements. It is commonly used to monitor the conducting thin film deposition process and the deposition chamber performance. As we can see, the table shows the resistivity of each material. Since the cross section is a rectangle, line resistance can be expressed as this formula. For a square sheet, the length is equal to the width, L equals to W, thus the two cancel each other. Therefore, the resistance of square conducting sheets defined as sheet resistance can be expressed as Rs equals to rho over T. As we can see, in Scratch, we ask user to insert the value of thickness. Then, we set the sheet resistance is equal to the resistivity is divided by the thickness. In the end of the process, it displays the result of sheet resistance calculation and the thickness. For example, when the user insert the thickness of 10 angstrom and the material is aluminium metal, thus the sheet resistance is that answer. So as we can see that our manual calculation is the same with our scratch calculation. Okay, last but not least, we can conclude that from metallization process that every material have different resistivity, right? So like we have go through at the previous slide that the resistivity of aluminium metal is 2.65 times 10 to the power negative 8. Diffusion of aluminium metal into the silicon form junction spikes. Second, the resistivity of copper metal is 1.68 times 10 to the power negative 8 ohm. We know that copper has poor addition and high diffusion rates in silicon and silicon dioxide. The diffusion of copper can cause heavy metal contamination and device malfunctions. In this metallization process, we choose aluminium silicon. Aluminium silicon can prevent junction spike by adding about 1% of silicon into aluminium to prevent further dissolving of the silicon. I think that is all from us. Thank you for listening and watching.